This is part one of my actual philosophy in my book Causation and the Universe, a bridge between the 1900s and the 2000s. And I call this "The next sentence is true, the previous sentence is false." This is philosophy. Preface part two. That's part two of my book Causation and the Universe. This part of the book is written by a partly schooled philosopher, namely I. If you have read the first part of the book, which is also written by me, even though I am not trained in physics, then hopefully you will not be so shocked or feel blasé, suspicious, angry, full of laughter, or superior when you start reading this piece. I put these two parts together in one book, and the presentation of my astrophysics theory comes first, because I hope people will read this controversial part as well. I can't say that this second part of the book is particularly easy to understand, but it is thoroughly elaborated, and the very simple heuristic mathematics in it is easy to understand even for primary school students. It is the simple heuristic mathematics that I set up that above all else proves that I have in fact refuted Gödel's incompleteness theorem. If you were not impressed with the first part of the book, that's the previous lessons I had, I do not think you should continue reading. The second part of the book will not be easier to understand. But if you were pleasantly surprised by the first part of the book, I think you should try to understand the second part of the book, especially if you are a philosopher. Here it is not enough with 240 plus 240 minutes to read and understand the text. You must study the text thoroughly and really make an effort to understand. It took me 12 years and 20 versions, plus even minor changes and clarifications, to get to the result in this part of the book. What sets Gödel apart from me is that he assumed that the German language is completely logical. Well, while I assume the opposite, that all languages are fallible, incomplete, and generalizing, which means, among other things, that sentences and words can be broken down into smaller components. It so happens that I am right before Gödel, and therefore it is possible to refute this cognitive giant and provide evidence that can be scrutinized. I present incontrovertible evidence against this incompleteness theorem, and at the same time I largely exalt the German mathematician David Hilbert Rip, who confessed to the formalists as opposed to the intuitionists. If I can refute Gödel, then I must also be able to refute Bertrand Russell. It is up to you to decide whether I have irrefutable proof, should you choose to study the text. The author. And that's what I wrote in the beginning of the second part of my book. And I'll start here. Gödel's theorem as it is believed to mean. Quote, in a book called Introduction to Mathematics by Stephen Cole Kleene, a standard work about Gödel's theorem, claims to contain the complete proof for Gödel's theorem with over 500 pages. On page 205, following a theoretical background of about 200 pages, Kleene gives a heuristic proof for the theorem, which I will present here. By the construction of a proposition. 1. A means that A is unprovable. Let us assume, as we hope is the case, that formulas which express false propositions are unprovable in the system, i.e. 2. False formulas are unprovable. Now, formula A cannot be false, because by 1, that would mean that it is not unprovable, contradicting 2. But A can be true, provided it is unprovable. Indeed, this must be the case, for assuming that A is provable, by 1, A is false, and hence by 2, unprovable. By intuitive reductio ad absurdum, this means that A is unprovable, whereupon by 1 also A is true. Thus, the system is incomplete in the sense that it fails to afford a proof of every formula which is true under the interpretation if 2 is so, or if at least the particular formula A is unprovable if false. The negation of A, not A, is also unprovable. For A is true, hence not A is false, and by 2, not A is unprovable. So the system is incomplete, also in the simple sense defined mathematically in the last section, if 2 is so, or if at least the particular formulas A and not A are each unprovable if false. The above is of course only a preliminary heuristic account of Gödel's reasoning. Because of the nature of this intuitive argument, which skirts so close to and yet misses a paradox, it is important that the strictly finitary metamathematical proof of Gödel's theorem should be appreciated. When this metamathematical proof is examined in full detail, it is seen to be of the nature of ordinary mathematics. In fact, if we choose to make our metamathematics a part of number theory, now informal rather than formal number theory, by talking about the indices in the enumeration, the Gödel numbering, and if we ignore the interpretations of the object system, now a system of numbers, the theorem becomes a proposition of ordinary elementary number theory. Its proof, while exceedingly long and tedious in these terms, is not open to any objection which would not equally involve parts of traditional mathematics which have been held most secure. End quotation. And I know what you're thinking now. This is just mind-boggling, not because it's true, but because it's so complicated, so difficult to understand for normal people and even for me. But it's what he said. And I can understand it, but I need to study it. So you should really study my book on the internet. Anyway, I will continue for a while, I think. No, I will not. I will continue another time, because this is just too much for anyone to understand by listening to what I say.